So this video is designed to outline some skills that we used during our discussions of Module 2 in Math 091. So hopefully this will give you some review of the things that you've learned. So we've talked about areas of rectangles. We talked a little bit about areas of the circles, or at least we did in Module 1. I think we hit that a couple of times in Mod 2. But the area of a rectangle is just its length times its width. So if, say, we had a 6-inch long rectangle that is also 3 inches wide, the area of any rectangle can be found by using the formula area equals length times width. So in this case, it would be length is 6, width is 3, 3 times 6 is 18, and we do have units, so report units, 18 inches. But it's not just inches, right? Because we multiplied inches by inches. So it's kind of hard to do that with that little notation that I used. So let me change it to a more familiar notation that we have worked with. And we have used inches for length. So that means that we have inches times inches, or inches squared inside of here. And where I wrote my answer, it should be 18 inches squared. Or another way you could write it is square inches. Same thing. All right, with a circle, let's imagine that this is a huge circle, and the radius of the circle is 3 yards. Okay, so the whole diameter of the circle would be 9 yards. And the area of the circle is pi r squared. So if our r is yards, I'm going to go ahead and put the units in here because both the 3 and the unit of yard are squared in this case. So we get 9, because 3 squared is 9, pi square yards. Or you could write it 9 pi square yards. Okay, that's SQYD. And the nice thing about a video is if I ever erase something too quickly, you can always stop the video, back up, and pause it to copy down or think about whatever I cover too quickly. We also have studied a lot about place value over and over and over again. So let's do just a little place value review. How many different ways can you think of writing 8.4 billion? All right, we're talking about a lot of big numbers. There's a lot of big numbers in the news these days. So 8.4 billion. Well, let's see. When we are writing numbers, we have up to 100. So you might say these are hundreds. Well, that place value definitely is. And in here we have our thousands up to 999 thousands. And then we have our millions up to 999 million. And then we have our billions. Okay, and beyond that, we're going to have trillions and da-da-da-da-da. Okay? So sorry, kind of ran into what I was doing originally. So what we have here is 8.4 billion. So it's like, here's the 8 billion, and there's where the 0.4 would go. So we could rewrite this 8 billion, 400 million, nothing in the thousands, and nothing in the hundreds. Okay? How else could you write that? You could write it 8,400 millions, because the millions start here. So you put the 8,400 in there, and then you add all 6 zeros that make up 1 million. So let me clean that up a little bit. There's an alternate way to write that. Here's another alternative for writing that. You could write it 8.4. Okay, and you've got those billions. Let's see, how many, when we're looking over to the right-hand side, where I put in all those zeros, if this is the first number in the billions right there, How many zeros do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So instead of writing 8.4 billion, like we did at first, we could write 8.4 times 10 to the 9th. In other words, a 1 with 9 zeros after it. So that would get us back, if we did that multiplication, to this form. Those are just some of the ways that you could write 8.4 billion, and this form is scientific notation. How do you know it's scientific notation? Well, the first number here is greater than 0, whatever that number is, and it's less than or equal to 9. So you have to have something other than 0 as your first term, and you only have one term to the left of the decimal if you have scientific notation. And then you're multiplying it by 10 to the whatever exponent you need, in this case 9. So let's compare that to 3.67 million. How could that be rewritten? Well, there's my 3 million, and then that would be 670,000, and we have nothing in the hundreds. Okay, it could also be rewritten 3,670,000. How else could it be rewritten? It could be rewritten 3.67 times 10 to the 6th. And another way to look at both of these exponential or scientific notation numbers is if we wanted to convert them back to an original number, 8.4 is multiplied by 10 to the 9th, so we would move the decimal point 9 to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, and fill in zeros as needed. And then, of course, we need to put in some commas. So let's do that. 1, 2, and I'm going to count from the right for that. So 1, 2, 3, there. Whoops, wrong function. Here we go. There. And another 1, 2, 3, comma, and 1, 2, 3, comma. And yeah, that's what I get. Let's do the same thing for our 3.67. I'm multiplying it by 10 to the 6th, so I go 1, 2, 3, 4, 5, 6 to the right. And then I put in commas, 1, 2, 3, 1, 2, 3. Okay, so 3,670,000, which I already wrote up there. All of those different ways of writing it are equivalent. Okay, so let's take a look at exactly how we name large numbers. Let's start kind of small. Let's start with this number. We read this as 547. Okay, and that's in the hundreds place, the tens for the 40, and the 7. Okay, that's when we just have 3 decimal places, the first 3 to the left of the decimal point that's right there. Okay, let's erase that. Let's add some numbers to this number and some decimal places. Let's add a 36 out here. And because it is in front of our first 3 places, we add the comma to separate it because it makes it easier for us to read the numbers. And each time we go over 3 more decimal places, like 3 here, 3 here, and 3 here, and 3 here, etc., etc. When we name a number, we're really looking at the 3 places within, say, the thousands. And we're looking at what number we see there, which if we're only looking here is a 36. 36. And then we add the name for those three spaces. So this is 36,000. And comma, we keep the comma. And then we just rewrite the name of the last three. 547. Okay, let's add some more digits. Once again, we will look at these numbers 3 decimal places at a time. So first, we will write and say 900, there are no tens, and there's a 0 there. So 908 million, comma, just like that, comma. We do the next 3 numbers. There's nothing in the hundreds, so that's just 36,000. And another comma for that one. And then the last 3 digits are 547. So the entire number is read 908,036,547. We continue that pattern to infinity. On the other side of the decimal point, it's a little bit different. Here, this would be read with the name of the last place here following it. So we would have this same number, 908,036,547, and we'll often say and to indicate the decimal point there, 1,379 and what place are they in? The 10,000ths. And the THS is what the TH is what indicates it's to the right of the decimal place. So this is 908,036,547 and 1,379 10,000ths. Enough place value for now. It's time to move on. Well, let's wrap up this video for now. I'll get it uploaded to YouTube. We'll talk about division, ratios, and other things in the next video.